All right, we'll go ahead and get started here. And so I would like to welcome everybody. My name is Jordan. I will be your host today from ARC. Thank you for joining. Once again, this is MLOps Isn't That Hard? Modular Stack with open source tools. And this is the part of the AI engineering job fair, once again brought to you by ARC. We connect great developers with companies from all around the world. And if you'd love to learn more about the companies that are hiring, we're sharing the link in the chat. Today, we will be learning about Modular Stack with open source tools. And to make sure you take full advantage of this talk, feel free to drop all your questions for our speaker in the Q&A section at the bottom of your screen, and we will answer them by the end of the talk. Also, don't worry about making notes, since immediately we will send the recording your way right after this call. So, let's welcome our special guest today, Hamza. He is the co-creator of ZenML, and he loves coming up with new ideas, implementing and launching data-driven products. His previous projects include PicHance and Skrillus. So, without further ado, Hamza, the stage is yours.
All right, thank you so much for the warm introduction. I'm also very happy to have people from all around the world, including my native Pakistan, in this talk. Um, and I'm just going to share my screen real quick. Everybody's on the same page. All right, so yes, exactly. So we are going to be talking about MLOps. We are going to be talking about why maybe it isn't as hard as it looks, and about modularity in your stack. I know this is a developer first community, and I really appreciate that. As was said in the introduction, I'm a developer myself. I've been doing software developing for the best part of 12, 13 years now, and a lot of that in machine learning. So I have developed and deployed machine learning models in production, and have built tooling around machine learning for a while now. So it's really cool to meet fellow developers. I am a software engineer at heart, so I always connect more with people coming from that engineering, computer science background. And yeah, it's always cool to talk with them about these topics because they always have a slightly unique take on everything. But yeah, I mean, like today we are going to be talking about MLOps. I know we've had a really cool talk already by Niels, and we learned about LLMs, and I'm just going to be talking about the backbone of all of that today. So maybe let me start from the very top. I know that this isn't sort of meant to be an introductory talk, but I do think that it still makes sense to learn about why MLOps exists in the first place, even though I am sure a lot of you are familiar. By the way, if you do have questions in the middle, I am glancing down and trying to see if you have questions. So I'll try to make this as um, yeah as like familiar as possible, so we can chat with each other. So right, let's start from the very top. So what I know a lot of you might be familiar with data science and be data scientists themselves. And oftentimes when we learn data science in university, it starts with something like that, right? It starts with something like a Jupyter notebook, where you're sort of, reading a CSV somewhere, you're fitting some, I don't know, principal component analysis, you're doing some NumPy, and then you're fitting it into a classifier. And while a data scientist can look at that and everything looks good, the problem is that if you give that to engineering, it's not that cool, right? So they're probably running around like this if you hand them over a machine learning model, especially with the new ones nowadays, which consists of code like that. And it's not just the code; it's a bit more complicated than that. And this is really why I think MLOps exists, because operationalizing machine learning is a bit different from researching, and oftentimes the personas are just simply very different. So again, I feel like this misconception is getting more and more less as time passes. Machine learning, everybody now knows that engineering is a big part of machine learning, but I really love this tweet thread or X thread from Chip Huyen, who basically said what we're all thinking. And I really think that it's way more than you would even think. Machine learning is a lot less about actual machine learning data science code that I showed you, a lot more about the engineering around it, especially if you want to scale it and really have it create impact. Of course, the machine learning part is still a big component of it, and you do still do algorithms and optimizing that stuff, but still, it's a lot more than that. So if you are entering the industry, you would do well to learn everything around machine learning, not just the machine learning part. ML in production. So everyone's that I speak to seems to think this is how it is, and especially if I talk to software engineers, they're like, "Yeah, it's like this, right? It's easy. You collect data, you train models, you deploy them in production." And I mean, in essence, in a very broad way, it is like that, right? You really can scope the project, you can collect your data, you can engineer the features, modify your data, train the model. It's a dot fit function, or sometimes it's a complicated function, whatever that is, and then you dockerize it and deploy it in production, right? However, the reality is that it's more like this, and I know that software engineering also looks like that. It's not just one single linear pathway, but to be honest, oftentimes people underestimate how these loops are making the whole process quite complicated. So these loops actually are data; they're not just code, right? So they're very hard to make reliable. So after you deploy, that's really where the trouble starts, right? Um, Essentially, you deploy a model, it's out in the world, and then it loops back, not just in the predictions it's making, but the data that you use to train this model is changing under your feet. And that's very different from software engineering, where think about it from the perspective of, I don't know, a website, right? In a website, you you create an XJS app and you create the Tailwind, whatever CSS around it, and you give it a class, and it's like, okay, it's a red class or it's a purple class, right? It's the button is red or it's purple, and it won't change. Like if you change that code and you test it and you make it go through this pathway of getting into production, it will not change. There is no other dependency. The input of the system is just code, right? But in machine learning, it's different. Like it's not just code that you're writing, but the input of the system is or the output of the system is derived not just from code but also from data. And think about it in a way that imagine you have a Python file and it's a requirements.txt file or a pyproject.toml file, and in there you have pinned a dependency. In machine learning, in like normal codings, we would pin the dependencies and we would dockerize it, right? But if you have an image in your model, that's like one row of that image slice. Every pixel of that image is almost like a dependency in your requirements.txt. Like it's just very hard to wrangle with, right? It's an infinite amount of things to deal with, and that's what makes, I think that's really why MLOps exists, right? Like it's sort of different. It's almost the same thing as DevOps, but it's just that data dimension really just changes the game. And of course, you have the addition of data scientists and other sort of personas that also make you think differently about this whole world. Yeah, so essentially, if you want to deal with these loops, right, MLOps is just a set of practices that aims to deploy and maintain machine learning models in production reliably and efficiently. That's all that is, right? So if somebody ever talks to you about MLOps, you're like, okay, yeah, it's about after I deploy a model, how do I automate it? How do I get it reliably into production? And it's different from DevOps because it's data in there. Right? You can just say that; they'll probably be satisfied. All right. So now that we established that, maybe I can touch briefly upon. I'm not one for hype cycles, but I have to say that I cannot ignore such a platform shift that is happening right now. Right, so we are in a very fundamental moment in our lives. I'm just going to hold on and take a question. So the question from Wad is, what is the best way to learn MLOps coming from a web development background? Do you recommend learning data analysis to begin with? I think if you're from a web development background, you're an engineer, um, and you could probably learn MLOps by just learning productionalizing web applications first, and then transitioning into productionalizing machine learning code. That would be for me a natural path. So learn about Docker, learn about Kubernetes, learn about how to scale software systems, and then maybe go towards how to scale data systems. All right. So as I was saying, so we are in the very early days of AI, new time. So well, let me say that again. We are still in very early days of AI, machine learning adoption. So oftentimes, I love what Elad Gil. You should read his blog. He's just very experienced in this field, and he he used to be at Google and Twitter, and he stood up a lot of ML systems, and he he really um, he really explained it well. So it's like he said that in the essence of if you look at it from a business standpoint, you could be very easily mistaken by saying that machine learning in 2011 whatever we had deep belief networks, and now we are going towards GPT and GPT-4 or whatever, right? And it's all been mapped out and it's like a straight sort of path. But to be honest, it's way more like a step function than a linear or path. So the sometimes there are these discontinuities in machine learning that happen that absolutely disrupt, and in the last case it disrupted the world. So it absolutely disrupts the field. So we are, once we go through these discontinuities, for example, a discontinuity was the transformer networks. GPT-3 was a good indication of what was to come. Then mid-journey or stable diffusion happened within 2 months. ChatGPT essentially changed the world. Of course, 4 months later, GPT-4 again changed the world, and the gap between these discontinuities is getting smaller. So actually, we are living in one of the most exciting times of machine learning applications that has ever existed. And for those of us who've been doing it for a while, it is almost mind-boggling how day-to-day things are changing. And I know that it might seem intimidating for those of you who are new to it, but honestly, it is really the right time to get into it, because like there are things that will get the enterprises haven't even adopted these things yet, so it's going to take some 6 to 12 months to even get POCs ready. So it's really the right time to get into this. And I think oftentimes when you talk about LLMs and large language models, ChatGPT, whatever, you often forget that MLOps is really the foundation, right? So we, I mean, we just heard now 1 billion revenue, 80 million a month or something, OpenAI is making from ChatGPT. And really, for me, this is funny that it just feels like there's like a whole mountain that the MLOps pipeline of GPT-4 is standing up, this $1 billion company, in like a few months. And I really do believe that the best machine learning applications out there are backed by the best MLOps systems out there. And OpenAI was never really known um, as the science company, right? But it was always known as the engineering company in the machine learning world. So yeah. All right. So then let's move forward. There's a few questions I want to take, but I'll take them at the end just for the flow. So how do you even start, right? I mean, I talked a lot about how we're going through this platform shift, and I really do believe that. But for those of you who are new to it or who have been doing it for a while, I mean, it can be a bit much if you look at things like this. So there is a very complex MLOps landscape and stack, that is forming, and in each stack component, there's many different things. So I'm I'm very interested to look how these things develop. But as we go through this platform shift, this is developing on its own. So it can be a tiny bit overwhelming. It used to be even back in 2019 and 18 and 17, and nowadays it's completely crazy, actually, even for people who've been in this world. So when you look at how to stand up MLOps systems, it often you can just get lost in what tool does what and stuff, right? So for me, what I'm trying to do today is really just talk about the stack in a very simple way, at least simple for to grasp, and try to see how we could create a system that can adopt to a changing stack landscape. Um, Before we get there, though, this heterogeneity does exist for a reason. So this is from our docs from ZenML, and I I think the way we break it down, orchestrator and artifact store and container registries and secrets managers, like all of these things are sometimes borrowed from classical development, but they do exist because every tool within these categories offers some advantages over the others. So for example, if you look at data validation tools like deep checks or evidently, great expectations, ylabs, ylogs, all of them do things slightly different. Some are doing model drift, model performance, data type, uh, can vary. Some do images well, some do, I don't know, data frames well. So it's not like these tools are redundant. And I also don't think that will collapse into one tool into each category, because it's just, as I said, the dimensionality of data is so much that you just have so many use cases. Um, and therefore, you just have to abstract it away to some extent, but you still need to be loose enough to be able to test all of these, and do what's best for your use case. Okay, so now we've arrived at, for me, the main point of the whole the presentation, which is pipelines, right? The way to sort of make sense of this landscape for me has always been to pipeline it together. If you look at machine learning, it is a very pipeline centric process, or it lends itself to pipelining. And the reason is, from the left to the right, you can see how you can make the tools fit together in and make the structure of your system sort of like Lego bricks, and then join them together through some sort of abstract framework. And then you can swap out different components. So for me, if you just think about that system like this, where data flows through the pipe and goes into different systems, that has always been for me the easiest way to deal with stacks, right? And how to achieve modularity in stacks. So if you look at pipelines, and for me they are the heart of MLOps. Um, Importer, analyzer, trainer, validator, deployer, very simple pipeline. But it gives you so much to think of these as independent systems, as independent services almost, rather than just Jupyter notebooks that are blocks. Even though you could sort of think of them Jupyter notebooks like this, but it just makes it so much better if you put it in a script and wrap something around it, which sort of makes it, yeah, it has properly defined interfaces. What does it give you? Well, you can separate the environment of running, where it runs, from the code. You could verge data and artifacts that flow through it. So if you define these interfaces, you could sort of start tracking things in these things. And if it goes back, you know exactly the lineage. Again, you have modularity. You could swap out the trainer step with another step and maybe add 3 more trainer steps and extend it. Again, you could track metrics and parameters. You could do data quality checks. You could detect drift. You could do CI, CD, CP. Um, so and you could leverage a lot of the existing knowledge that we have of software systems and map them on to this, if you sort of start treating them as software assets or pipeline assets. And ultimately, in MLOps, I spoke a lot about the word reliability. The word reliability goes along with reproducibility. If you can reproduce something reliable, it is often reliable. If you can reliably reproduce it, software works like that. And especially when I talk about these loops, then lineage and provenance is a big thing, right? You need to know who trained what at what time. I'm talking about these big LLMs, right? But they've been trained on big data, and if for example it starts to hallucinate, you got to know why did it. I mean, even if you don't know why it hallucinated, you can at least trace back what was the chain or the trace that led to it hallucinating and what it said. So you need to get a handle of these systems, right? So for me, essentially, pipelines are really at the very heart of the entire process. And if you can think about machine learning in terms of pipelines, then the stack around it gets easier. And this is where I need to talk about the tool that we're developing. I am the co-founder of ZenML, so disclaimer there. But I mean, there's a reason I'm giving the talk, because I really believe in this. So um, ZenML itself, what is it's open source, so it's free to use. It's an extensible framework that allows separation between your code and your stack through very easy to develop pipelines that sort of float through stacks. So we give you an interface to create pipelines, and then we give you an interface to create stacks, and we put these things together. And we wrap it around an experience that probably makes it a bit easier than doing it all yourself. Um, well, that's the hope, at least. So we call it, yeah, like the experience layer, or whatever you want to call it, something like which is on top that wraps all of this and glues it together. How does it work concretely? So I know you're all devs, so we need to talk about that in a Python set. I just give a second for everybody to read this. So Python code, right? So very simple. You can see that what's happening here is you're just creating a step. You're passing things in, normal Python stuff, and the only thing you do is you decorate it with a decorator. This is very similar to what you might have seen with Flight, for example, the talk before. And I'll talk about the differences if some people are interested. And then you train it, and then you return something. And then I think the interesting part here in this slide is that you can define your stack, for example, at the step level. So you can say my experiment tracker for this particular run should be MLflow, or weights and biases, or some other experiment tracking tool in the categories we've defined, and you can sort of be modular accordingly. Um, And yeah, I'll go more into depth of that when we actually do the thing. All right, so what are stacks? So I talked about pipelines. Pipelines are like the heart of the system, and then you have stacks. So pipelines run on stacks. So users create these stacks, whether through the dashboard and stacks. Think about stack as a window into your infrastructure. So it's configuration of your infrastructure in a modular way. So you can register your orchestrator, for example. And this is maybe where I can draw the difference. For example, Flight for us would be an orchestrator. So Flight, the tool that was just in the talk before, is a system that lets you scale up in a massive way orchestration, right? And you have other tools like that, like Airflow and Kubeflow. And you like ZenML doesn't do that. It just provides a window into that tool, and you can configure any orchestration system in the back. Similarly, artifact storage. So where does data get stored when you go through the pipeline? That's also something configurable. You could store it locally. You could store it in an S3 bucket or whatever. And the key is that you don't want your code to be sort of tied to that, because you don't want to be locked in, because you want to be modular, right? So let's move forward. I mean, of course, the framework handles all the rest. Blah blah blah. It's really great. All the different roles can then look at it. Right. So let's go through a quick example. I will do a demo in a second. Let's say you didn't have ZenML and you wanted to do what I just said. So what you wanted to do was create a pipeline, and at the end you wanted to upload artifacts in S3 or Azure Blob Storage or Google Container Storage. Then you would create a function like this, and maybe you would at the end you would do s3.upload artifacts, and then it's hard to switch between these. And you could potentially abstract it out to a cloud, like a class, and then you have to implement the individual classes and implement the upload artifacts function. It's just a very simple example, but serves the purpose well. And with ZenML, you would just decorate it with add step, return data directly. You don't need to figure out the serialization and storage, and then just configure the artifact storage outside of the code. So you would just say, okay, just go to S3 or go to Azure, and then register the stack. And then if you run the same code again, ZenML picks up that, okay, this time it wants to go to Azure, this time it goes to S3, or it wants to orchestrate somewhere else. So that serves as a very simple example of how modularity could work on one aspect of machine learning. Cool. Okay, now is the time for a demo. Let me just take a look at if there are any questions. I'm just going to ask them before. So working on auto-updating maintenance for MLOps models to prevent for algorithmic trading, any structural ARB trade, it's key for making money and expanding. Any work interest in auto-updating MLOps models. Auto-updating MLOps or ML models are very hard. So if you do have a pipeline that does what I just said and grasps the data accordingly and makes sure everything is like sort of tracked, and you know what's happening, then it's way easier to achieve auto-updating ML models, even though there's a lot of caveats and it's very hard to do. Your thoughts on general AI will work and who is leading the pack on development? Obviously, in the LLM world, OpenAI is leading, but I do think that the open source models are very strong. And I do think that there's no one leader. So it depends on the domain. What's the meaning that we are in the mist? Must adopt new tools. You don't need to adopt new tools, but there's many. So like different tools do different things, and you don't want to be locked into any. Although you could, but it's probably better to just build a system which is agnostic to it. What working methodologies would you recommend for a team starting to implement MLOps? Oh, that's a good question. That's something I do all the time. Talk to teams who are doing that. Start simple and be pragmatic, and abstract things away. Will quantum computing help accelerate general AI development? Yes, that might be another step function that we can't even think of right now. I do think that fundamentally right now we're bottlenecked by backpropagation. So we need to move forward from that. I don't know, maybe it's a different algorithm, or maybe it's just raw compute. Any work interest in auto-updating? Calvin, if you could talk a bit more about auto-updating MLOps models, I would love to answer that question. So just maybe write me what you mean exactly. And now I'm going to switch to the demo. Thank you for your questions. I love interacting with audiences like this. So. All right, so what are we going to do in the demo? It's very simple. So here's ZenML. You can see this is our dashboard. You have lots of tabs here, and then you have stacks. So I talked about pipelines and stacks, and these are the two things you see at the top. If you go into a particular stack, for example, let's go into local_demo, you can see that it consists of different types of components: experiment tracker, data validator, orchestrator, artifact store, some of the things we mentioned before. But if you go back into my slide deck here, you can see there's many types of stack components: alerters, annotators, model deployers, image builders, model registries, all that thing. So you could sort of configure everything there, or you could do it on the command line. On one, for example, let's click on the artifact storage here. You can see that this is just default. So this particular stack is a very local stack. So everything here is local. There's nothing here which is defined, which is going over HTTPS, whatever. So all of these tools are open source and they can be used locally. Evidently is a data validation tool. MLflow is an experiment tracking tool. One of them does data validation reports. One of them tracks experiments and hyperparameters. The artifact store is where the artifacts are stored. And in this case, it's just local storage. And orchestrator is how the pipeline is run. So is it running locally on my machine? Right now, if I do default, then it's local. But if I can also run it on Airflow, or I can run it on AWS SageMaker, I can run it on Google Vertex pipelines, I can run it on Kubeflow or Flight. So you could configure that here. And if I did want to run my machine learning code on that stack, what I would do is, well, first I have to write some code. So my code here is written here. I saved everybody the trouble of actually writing code. But you can see, for example, the code is very simple. So it's just like Python code. You just define what comes in, you define what comes out, and this is my step. And if I go into the pipelines folder, it also shows you how these steps are linked together. So for example, this step should happen, then this should happen, then this step should happen, and then this step should happen. So very simple, right? Very simple. But there's many things around that, which is very interesting for when you try to switch around the stack. So anyway, at the end, I'm just going to run this pipeline. So I'm just going to call it this pipeline in Python. I would not recommend notebooks. Do this in code, although ZenML works in notebooks as well. So the first thing I have to do is connect to my server. I've already done that, but then I have this command line where I can literally do many things that I can do in the dashboard. So in this particular case, I'm just going to list all my stacks. So you can see, for example, here I have many stacks actually. So there's many stacks here. But what I was interested in is the one which is here, local_demo. So I can just do ZenML stack set local_demo. And what that does is it configures my local ZenML to point to that stack. So if I describe the stack, I will now be able to see that it's the same stack component. So I have the default evidently local MLflow, you can see. And if I wanted to further define these and see what the artifact stores are, for example, I could list those. So I could list all my artifact stores and sort of configure this at will, a bit like Lego bricks, right? And you can see that I have GCP, I have S3 and all that. And we'll see how that works. Right. So what else is there left to do? Nothing, just to run it. Okay. So when I run it, it's just Python. So it's going to use the local orchestration system. So it's going to pick up my virtual environment. Excuse the warnings. I haven't updated my code. But you can see that essentially what it's doing is it's initiating a new run, doing all of that tracking that I was talking about. And if I go over to my dashboard, I would actually be able to see this run happening. You can see here. So it's running. So you can see the data splitter event is happening. And I can see, for example, the code here as well. I can see the configuration. I can see what sort of Docker requirements it needs, all the environment, the caching parameters. And then I can also see the code of how to get these things programmatically, not just from the dashboard. And from the previous steps, I actually see the data. And this is what I want to focus on. It's all about the data, right? So you can see that if I click the loader step produced two artifacts, df and ref color, and you can see that where it's stored. So it's stored actually very locally to my machine. I can, if I go back to my machine, I can literally see that it's stored in this folder. And yeah, it's in a Parquet file. So you can see that. I can describe it. It's all Parquet. And that ZenML took care of for you. And you can load it into code if you want it. Let me just refresh this pipeline so it doesn't seem to be auto-refreshing. And you can now see also, if you wanted, you could see many things around that where it was stored. But look, I mean, what I really want to focus on here is that it ran locally and it stored the data locally. It gives me all the reports that I need really to reproduce this experiment, and I can go back and see it, and it does caching and everything, which is very useful if I'm running it locally. But let's say at some point I don't want to run it locally anymore, so I want to run it on the cloud. So okay, let's do that. What I'm going to do here is I'm just going to switch over and create a new stack. So let's register a new stack, and I'm going to call this stack my cloud stack on AWS, whatever. Let's say AWS. So this has all these components have been configured for me by my MLOps team, assuming I have an MLOps team. But even if you're a data scientist, you can do this. So you just need to connect your infrastructure. And I'm going to be creating a stack which has a Kubernetes orchestrator. So this orchestrator, basically, you can click on it, and it also tells you what it does. Oops, bugging out a bit. So yeah, click on Kubernetes orchestrator. Yeah, so that's going to be just a Kubernetes cluster which is running on my AWS. I am going to be using an AWS artifact store here, and I am going to be using a container registry this time, because this time the cool thing is that I want to run this on the cloud, right? So I want to be able to build Docker images now, even though I don't know how to do that maybe, but still I need a container registry to build Docker images. I select that. I'm still going to be using evidently. That's fine. And I am going to be using my AWS ML flow tracker because I want to stay in AWS. And yeah, I could do more, but let's stop here. So let's register that stack. Okay, perfect. It got registered. So that's my cloud stack on AWS. Let's copy that. And now let's go back to my terminal. So if I do a ZenML stack list, I would probably be able to see that stack out of the hundreds of these. Yeah, so it's my cloud stack on AWS, and I can now switch it to my cloud stack on AWS. So I'm just setting a new stack now with more components. It's switched, and I'm going to run this now, the same code, exactly the same. And now ZenML will behave differently. So it initiates the new run just as it was. It's going to use the same version 2 of the pipeline. But now see what it's doing. It's actually going in and building a Docker image from all the information. It's pushing the Docker image to the container registry that I just spoke about, which I just configured, which is on AWS. And then it's going to launch. This is the cool part. It's going to launch a Kubernetes pod right in my Kubernetes cluster. And I didn't even need to authenticate, by the way. So this is all done through service connectors. So I'm not, well, I mean, I have logged in now for the demo, but I didn't need to be. So any data scientist could do this. They wouldn't even know what's happening really. They would just change the stack, and that's the dream. And then it would run on production, right? And you could also federate this through I don't know, something like CI/CD for GitHub Actions or something. I'm doing this now manually, but what's cool is the same pipeline is now going to be running in different pods. And let's just take a look at them. So ZenML helpfully gives you. I'm not logged in actually. So let me see if I can show you an advanced use case. And this should work technically. If it doesn't, we'll just go to the dashboard. Yeah, so this logged me in now to the Kubernetes cluster. Let's see if this works now. Oh yeah, now it works. Okay, cool. So I showed you another feature now. So as I said, I wasn't logged in before, but ZenML has this service connectors, which are secure roles in AWS, and it uses short-term tokens for me to authenticate. And you can see now that this is a pod in Kubernetes. So I did a kubectl logs, and now it's running the pipeline. So if I switch back to my server, it should at some point be giving me now a new pipeline. And this new pipeline should be running on that new stack, right? So let's see, did it fail? Okay, it failed. Anyway, it doesn't really matter. So you can see what I wanted to show you was that here it's the same data, it's sort of the same data frame, but it's now stored in an S3 bucket here, which I configured. And I can load it directly again. And if I click on visualization, I can also visualize this data. If it doesn't kick me out for some reason. But anyway, I can visualize it. I can see the same things that I did before. All the metadata, for example, this is the data frame. And you can see that everything is versioned and tracked by ZenML, and you really went into production like that without a second. So you could also point it to other things, and it would work similarly. And this is really the power of modular stacks, that you don't need to be tied to a particular technology, but you can still achieve tremendous things. So I don't know why it's bugging. Always live demos are a bit weird. Anyway, so what I also did was you might remember that we used MLflow here. So in MLflow, which is just an experiment tracker, I just wanted to show you. I mean, now the run didn't happen, but if I click on, for example, the one that I ran just before, you can see all the parameters are tracked. All the goodies of MLflow that you would like to see are tracked, and even the model is stored. So we have integrations to so many different tools that you don't even need to even know about, but you could still use them and achieve the full power of something like MLflow, which is one of the most popular tools in this space. And that would be configured and linked to your pipeline. So you can see this pipeline, but this pipeline experiment run was created automatically by ZenML, and all the data was sort of linked together. And if I go into, for example, so this you can see here, you can see this ran on my stack. But if I, for example, look at the previous pipeline that ran through successfully, if I go into my evidently report, I could also, for example, see all of my data validation steps and the report that came out of it. So evidently is another tool that produces a report like this. And you can see that you can now really, in one single glass plane, see all your data validators, your MLflow experiments, your artifacts, orchestration runs, your Docker images, everything in one big glass plane, easy to use, and you can switch just like that. Yeah, so I don't know much about data distributions right now and for this data set, but if you were so inclined, you could now analyze it and change the pipeline, run it again, and compare them. Okay, so let's go back to the presentation. All right, let's go back. There's one question which I liked, which is, what would I need to do to get the same results if I did not use ZenML for the same pipeline? If you did not use ZenML for the same pipelines, you would be using some other tool, and then you would just be putting things together, and sort of you would have to do that manually. So we take away a lot of that complexity for you, and everything is open source, so you can also contribute or fork it or do your own stuff. So it's like a framework like React. All right. Yeah. So what basically does that do? So what you do is your pipelines connect and travel across stacks. So you can start very locally. I mean, somebody asked now in the call, hey, what do you do when you start? So I would say start local, right? You don't need like a cannon if it's a gunfight. If you have one model, then you should just start locally and still try to create pipelines, in my opinion, and try to incorporate tooling. And then at some point, you can go to the cloud if you want to scale up, or if you have more models, or if you have more teammates. And then what we recommend and what our users do in production is they create different stacks. So they have a local stack, a staging stack, a production stack, and they use CI/CD or something to go through those and do different pipelines on different stacks, which just build on top of each other, which is a bit more advanced. But that makes everything sort of connected, and the same code travels across different stacks. Yeah, and that's pretty much it. I know I sort of rushed through a bit of that, but I hope you got the gist. Essentially, maybe my TLDR, MLOps is a huge thing. Pipelines lie at the heart of MLOps, and you should really start thinking of how to break your machine learning systems into pipelines, which are software engineering principles. And if you have a good handle of your pipeline, you will have a very good handle of your stack. And if you do it well, you might be able to abstract enough stuff away that your data scientists won't even need to know about the infrastructure, the stack, and they can just do the code that they're good at. And if you're an engineer, you can set up the infrastructure for them and scale it up as you want. Cool. That's it for me. I think I'm 2 minutes before. So I'll use those 2 minutes to retell what we already said before. So we did Adam, so my co-founder, he spoke about the company. We are growing and we are growing strong. So we are growing the team. It's a very small team still, still only less than 20 people. So if you want to be part of it, we are looking for a very talented front-end engineer. So that dashboard experience is now being reworked. We have a new design upcoming, and we also have a cloud product, which we're building on the side. So those two things mean that we need front-end experience. If you're familiar with Next.js or React, and you have a good sense of UI UX, would love to have you. We are very remote friendly. Half of the team is remote all over the world, so it doesn't matter where you are. Just apply. careers@zenml.io.
Amazing, Hamza. Thank you so much. I walked into this call thinking I'm not going to understand anything. Great job of explaining everything at the beginning. You lost me when you got into the code. As a recruiter, that's just something I'm not going to get. But I do have one question that we love to ask all of the guests that speak here. What is a piece of advice that you have for us that you wish you had known 1 year ago?
I I wish I would have known to invest in Nvidia stock. But I mean, in all seriousness, um, I think advice is. I really struggle with advice because I've been given advice which sort of sounds good when you hear it, but when you apply it to your own life, it's very doesn't make sense. But I really like, for me, the thing that always stood strong is really do not compromise on taking risk in your life, and time that risk well. So if the risk equals reward, so if you have to, people often think that life is like something which is very um, unchangeable and you live sort of in life. But if you really think about it, you can shape your own life very well. And a lot of people, I feel like, don't feel like they have the control to change their own life and make an extraordinary life happen. And to be honest, it really starts with going outside of your comfort zone and taking a risk. So for me, do take risks, educated risks, and try to enjoy the ride as it happens.
That's beautiful. I don't think I have anything I can say that would be as nice as what you just said. So
You put me on the spot there, but
well, I just want to say I do appreciate you speaking today, Hamza. Really do, and I'm sure everybody else here does as well. And thank you, everybody here, for joining. If you would like, you can follow Hamza on any social media channels that he has. You can see it right there at the bottom. And if you enjoyed it and want to learn more about the companies that are hiring, we have pinned a link in the chat. So thank you again, and we will see you soon.
thank you.
Bye, everybody.
Bye. should we have answered some of the questions there that were left? I think we.
I think we got to most of them. I don't know.
I mean, if Sylvia is still here, I think we have one question, but
Yeah, if there are any questions, if anybody wants to ask while they're still here, feel free.
Yeah, I'm gonna hang around for a few more minutes. I think Sylvia's still here, or well, I don't know. What do you need to configure all the things you showed? Suppose you start from scratch. So I mean, I can show you that. So maybe they see the recording, so then you can follow along. You could, if you started just from scratch, you could go to our docs, and we have stack deployment. And here we talk about how to deploy stacks. So we have even a separate tool called ML Stacks, which just launched, by the way. So if you go to ZenML-io/ML Stacks, this is a whole other tool which allows you to deploy machine learning infrastructure on AWS. So at the end, it just comes back down to running one command, ZenML stack deploy -p AWS, and then a few other parameters, and then that tool actually deploys a lot of that infrastructure for you that you saw here. And then you also have the stack configured. So you don't even need to do much of op stuff. You can literally just run that one command. Hopefully it works. If it doesn't, report it to us. And then you can just run the pipeline. Is there a plan for, well, I'm now switching from chat. +1 to the Terraform question. Yes, actually ML Stacks is built on top of Terraform. So you can see it's 87% HCL. These are all Terraform scripts that we wrap Python around. So you can deploy your infrastructure with ML Stacks right now, or through ZenML with ML Stacks, and it is Terraform. So we are going to publish those in the Terraform registry as well. If you want to just use raw Terraform, but we build ML Stacks because you sort of need to take that configuration and still pop it into ZenML, and that just makes it easier. Is there a plan? Okay. How could a full stack React developer benefit from AI? I mean, she might not have direct developments on its models, but somehow could use it in projects. Well, Octay, the big thing is that currently, I think this is the first time in the time I've been doing machine learning, is that it's very easy to use machine learning as a software engineer, as a web developer. I mean, I'm sure you're using Copilot or Cohere or something like that to help in your coding. But you can use the APIs and stand up a very cool ML system still. You would still need to interact with some of these tools because you still need to get a handle of hallucinations. But if you're really not training models yourself and deploying them yourselves, you could just use the APIs, and might be a good way to learn about them. So maybe use OpenAI's APIs just to fine tune a model, or yeah, start with their I mean, Hugging Face is another thing. So if you go to huggingface.co, they have a lot of like pre-made models that you could just take from their model zoo. And a full stack React developer could get into machine learning through those tools. Any more questions? All right, looks like we're out. So thank you so much for the invite. Like Jordan, really appreciated the Art Dev team for hosting this fantastic event. I really hope to connect with the community more.
Well, we really appreciate you being here today, Hamza, once again. Thank you for your time, man.
Cheers. Have a good one.
Man, have a good night.
Yeah, I'm going to sleep now. Bye-bye.
See you.